All right, so we're going to do 5.4, and we're just going to talk about sum and difference formulas. Okay, so just like the other day, we're just going to do a ton of examples here. You have all the formulas in front of you. We're going to use them all. You do have to memorize them, okay? So let's start here. Well, let's think about this. If you have 15 degrees, 15 degrees is not a unit circle value, correct? But you can represent it differently to get 15 degrees using unit circle values. So, do you agree that 45 degrees minus 30 degrees is 15 degrees? Okay? Now, 45 degrees and 30 degrees are unit circle values, and that will help us. Okay? So that's what you want to do, is you want to choose values that will either add or subtract to the angle we're really looking for. So, if I want to find the sine of 15 degrees, using exact values, meaning no calculator, meaning use your unit circle, okay, then I want to think about a way that I can represent 15 degrees using those unit circle angles. So again, 15 degrees would be like 45 and 30, right, once you subtract them. So this would be the same thing, sine of 15 degrees would be the same as if I had the sine of 45 degrees minus 30 degrees. Do you agree with that? Okay, so now what you want to do is you want to look on your formula sheet, all right, and find the one that says sine of u minus v. So do you see that? Okay, because u in this case is 45 degrees and v is 30 degrees. So the sine of u minus v is sine of u cosine of v minus the cosine of u sine of v. Okay, so this is the formula that we would use for this one. Does everyone see out of the 6 why we would choose sine of u minus v? Excellent. So now all you have to do is substitute in the values. Okay, so we're going to do the sine of 45 degrees minus 30 degrees. And then we're just going to plug in our u and v. So I have the sine of 45 degrees times the cosine of 30 degrees minus the cosine of 45 degrees times the sine of 30 degrees. Your unit circle is imperative in this section. Okay, you have to know it. So now we just simplify. So what is the sine of 45 degrees? What is the sine? What is the y value? Root 2 over 2. What is the cosine of 30 degrees? Root 3 over 2 minus the cosine of 45 degrees, just root 2 over 2, and the sine of 30 degrees is 1/2. Okay? Now we multiply. So what's root 2 times root 3? Root 6 over 4 minus root 2 over 4. You just want to combine them into 1. So the sine of 15 degrees is equal to root 6 minus root 2 over 4. Easy, right? It's literally knowing the formula, plugging it in, knowing your unit circle, and then simplifying. That's all it is. Okay, so let's try another one. How about if you had the cosine of 15 degrees? Okay. Again, you'd want to represent this with values of the unit circle. So 45 degrees minus 30. Okay, so look on your formula sheet. Which one would you use? Cosine of u minus v. Everyone agree with that? So the cosine of u minus v is the cosine u cosine v plus the sine of u times the sine of v. And now we plug it all in. So in this case, again, u is 45 degrees and v is 30 degrees. So you just substitute in your angles. Okay, once you do that, now all you have to do is think about the unit circle. So what is cosine of 45? Root 2 over 2. What's cosine of 30? Root 3 over 2. What is the sine of 45? Root 2 over 2. And the sine of 30 is 1/2. So, final answer, the cosine of 45 degrees minus 30 degrees, or better yet, the cosine of 15 degrees, right, is equal to, isn't that just root 6 plus root 2 over 4? Okay. Questions? Can you take a guess what example 3 is going to be? The tangent of 15 degrees. Let's try it. Listen, you're going to need some space for this one. Okay, this one is a lot more work. Tangent is never fun. Alright? So you might want a little bit more space if you're trying to cram it into the bottom of your page. Alright, so the tangent of 15 degrees, we're going to do the same thing. We're going to do the tangent of 45 degrees minus 30 degrees. Alright, so what is the formula? Everybody agree we're going to use tangent of u minus v? Okay, so that's the tangent of u minus the tangent of v over 1 plus tangent u tangent v. Now, I'm assuming you can see why this is a little bit more complicated, right? We have a fraction going on, and, you know, it's just going to get messy, and that's okay. So, here we're going to get the tangent of 45 degrees, because remember, u, again, is 45 degrees, and v is 30 degrees. So we're going to get the tangent of 45 minus the tangent of 30, divided by 1 plus tangent of 45 times the tangent of 30. And now we have to think. So where or what is tangent at 45 degrees? 1. That one's easy. How about 30 degrees? Root 3 over 3, everyone agree with that? Okay. Over 1 plus tangent of 45 is 1 times root 3 over 3. Okay, you with me? So this is 1 minus root 3 over 3 over 1 plus root 3 over 3. What should we do? You could get a common denominator, right, in the numerator or the denominator. Agree with that? That it would be 3. Couldn't we also just multiply everything by 3 right now? Right? And clear it all. So you could do it either way. Let's get a common denominator, because that's what we've kind of been doing with those identities lately. So if I go through and I get a common denominator, this should be 3 over 3, and this should be 3 over 3. So then this is like 3 minus root 3 over 3 divided by 3 plus root 3 over 3. What's the next step? Yes, multiply by, well, almost. Not time to multiply by the conjugate yet. What can we do next? Multiply by the reciprocal, right? I could change that compound fraction into 3 over 3 plus root 3, right? Dividing by this is the same as multiplying by its reciprocal. So now I get these 3's to cancel, and I'm left with 3 minus root 3 over 3 plus root 3. Yes?
You don't mind if we just clear it with the 3?
Not at all.
I just multiplied that.
Not at all. That's what I would do, would be the faster way.
Okay, and then you multiply by conjugate.
Yep, and now we can multiply by the conjugate. Do you see that we have to multiply by the conjugate? Okay, because we have to rationalize it. So we're going to multiply by 3 minus root 3. Alright, and that's going to give us, let's see, 9 minus 6 root 3 plus 3 over 9 minus 3. Okay, when we combine our like terms, I have 12 minus 6 root 3 over 6. This is a common factor between both of them, so you can divide and get 2 minus root 3. So the tangent of 15 degrees is equal to 2 minus root 3. Tangent's not super fun. A lot of work there. Okay? Same idea, plug it all in and simplify. Just the simplifying takes a lot more time. Any questions? Yeah?
Would it be the same thing if you did the sine of 15 degrees divided by cosine of 15 degrees?
If you were to plug them into the formulas, yes. Ready to move on? Okay, so now you see how to plug it all into the formula and simplify. So now let's go this way. Example 4. Given the sine of 140 degrees times the cosine of 50 degrees plus the cosine of 140 degrees times the sine of 50 degrees. Write the expression as sine, cosine, or tangent of an angle. So what am I doing here? Pardon me? Yeah, I'm looking for what formula this matches. I'm going backwards this time. Now I have everything that's plugged in. All I need to do now is actually just figure out what formula they were using. So which one has sine times cosine plus cosine times sine? Yeah, sine of u plus v. So this represents the sine of u plus v because it takes on this pattern of the sine of u, cosine v, plus the cosine u, sine of v. All right, well, what's u and what's v? Yeah, u is 140 degrees and v is 50 degrees. Plug it in. So the sine of 140 degrees plus 50 degrees you could give me, or you could give me the sine of 190 degrees. Either one of those answers is acceptable. Okay? That's it. That one's easy, right? You just have to know the formula, figure out what pattern it takes on, and then add the two angles or subtract the two angles. Sound good? This is a lot better than everything else we've done, isn't it? So you have to memorize the formulas. Okay. Well, we'll do your favorite thing now. Verify. Okay? You love this stuff. So the sine of 3 pi minus x equals the sine of x. Okay, so now we're going to try to verify this. So in order to verify, remember you pick the more complicated side. You can only work on that side. You have to write down equals the other side each step. We're trying to get to the end where both sides match. Yeah, Arwen?
So for the last one,
Yeah.
So you can write like 140 times 15 and still be right.
Yes, you could either write this or you could write this.
Okay.
Either one is right. Any thoughts on, let's just start out, which side should we work on? The left. Okay. So now when you see this, before you saw this section, hopefully, you'd be like, I don't know what to do here, right? I'm kind of thinking, I'm not really sure what to do here, okay? But now that we know that these formulas exist, most of the time when you get stuck, it's something on the formula sheet, okay? So go to the formula sheet and see if there's anything that you could use that we've been talking about in this section to kind of start working with this left side. Any thoughts? Yeah, so the sine of u minus v. Now in this case, what would u be? 3 pi, and what would v be? X. Okay? So that means what we're going to do is we're going to plug into this formula. So the sine of u minus v is the sine of u. So I have the sine of 3 pi times the cosine of v, which is the cosine of x, minus the cosine of u times the sine of v. Okay. All right, well, that doesn't look like it got any easier. Any thoughts? Substitute for the unit circle value. So 3 pi isn't a unit circle value, but pi is, right? Isn't 3 pi and pi the same thing? So maybe just make yourself a note. I wouldn't necessarily expect to see that in your work, but just so you can reference this later. Remember, you can take out that full revolution that's within there. Okay, so what's the sine of pi? 0. Yes. So 0 times the cosine of x minus, what's the cosine of pi? -1. So -1 times the sine of x. I'm trying to get to sine of x. So 0 times cosine is going to cancel. And -1 times -1 is +1, leaving me with sine equals sine. Easier than 5-1 to 5-2, isn't it? Right? You just need to know a formula. Plug it all in, use the unit circle value to help you get there. Okay, we're going to keep going. Introduce some more stuff. Ready? Yes? Oh, so many. I have 3 more left. Can I move this now? Okay. So, example 6. Find the exact value of sine of u minus v if the sine of u equals 5/13 and 0 is less than u, which is less than pi/2, and the cosine of v is equal to -3/5, and -pi/2 is less than v, which is less than pi. Okay, now I am hoping that based on what we've done this year, you're going to know what to do here. I know you've never seen this type of problem before in terms of the sine of the u minus v, but is anything standing out to you on like what the first step should be? Yes. Do you see that you need to draw triangles here? These are not unit circle values, right? So like we can't use the unit circle values. This tells you where to draw the triangle, doesn't it? It's a restriction. So let's start there. We're going to draw the triangle for u. So there's 2 triangles going on here. There's a u and then there's a v. Okay, so we got to do both. Now if this is between 0 and pi/2, which quadrant should I draw this in? 1. So I'm going to draw a triangle in quadrant 1. Remember that your 90-degree angle has to be at that horizontal axis, right? Our reference angle is here at, it's not really theta, it's u, at the origin. Okay, so sine is opposite over hypotenuse. Both of our signs are correct because everything's positive in quadrant 1. Okay. They're telling us to evaluate the sine of u minus v. So in order to do that, take a look at your formula. In order to do that, don't you have to know the sine of u and the cosine of u? Well, I only know the sine of u. So to find the cosine of u, I have to use Pythagorean Theorem or a special right triangle. That's why I have to draw the triangle. So here I get 12, right? It's 5, 12, 13 triangle. So for this triangle, I know that the sine of u is 5 over 13. And now I know that the cosine of u is 12 over 13. Okay, so now I have enough information for half of my formula. The other half of the formula comes from v. So now I'm going to draw a triangle for v. And I want to decide which quadrant do I put this in. So from negative pi over 2 to pi, where does that go? The third. So this is negative pi over 2. This is pi. It's got to go in the third quadrant. Okay. Cosine is negative 3 over 5. I know that my x value is negative, right, in quadrant 3. Also, my y value is negative there as well, right? So shouldn't this be negative 4? So 3, 4, 5 triangle. And then I'm just going to take some notes. So the sine of v is negative 4 over 5. And the cosine of v is negative 3 over 5. And now I'm ready to use my formula. Okay, so now I plug in my formula. So the sine of u minus v, I'm just going to write it down, is the sine of u times the cosine of v minus the cosine of u times the sine of v. And now I'm going to plug in what I know. So what is the sine of u? 5 over 13. So this becomes 5 over 13. What is the cosine of v? Negative 3 over 5. What is the cosine of u? 12 over 13. And the sine of v? Negative 4 over 5. And now I just simplify it. So 5 times negative 3 is negative 15. 13 times 5 is 65. Here I get a positive 48 over 65. Combine like terms, right? Add those numerators and we get 33 over 65. Again, not really difficult. We've done this lots of times where we've drawn the triangle, had to use Pythagorean Theorem, evaluated those trig functions, right? All you got to do is know the formula, plug it in, and simplify. All right, moving on. Evaluate the cosine of the arctangent of 1 plus the arc cosine of x. This was not your favorite thing from, what, 4.7? Okay, so this is this inverse stuff. We're still drawing triangles, right? Still what we have to do. What's going on here? Like, what does this even mean? Because this is like a lot. Can anyone see? No, nothing to do with secant. No identities there. Think about the formulas. Go back to your formula sheet. What does it look like? Cosine of u plus v. Okay? So cosine of u plus v is what we're going to work with. Alright? Again, this is u and this is v. So we're going to draw a triangle based on that. Okay, so we're going to have two triangles again. So our triangle for u, okay, we have tangent is 1, which means the opposite over the adjacent side is 1, and that is root 2. Now, did you really have to draw a triangle for that one? No, because tangent of 1, isn't that a unit circle value? Right? Tangent is 1 at 45 degrees, or pi over 4. Don't we already know sine and cosine then? Isn't sine root 2 over 2 and cosine is root 2 over 2? Which is the same thing we'll get here by drawing the triangle. But you could have used the unit circle there. So the sine of u is root 2 over 2, and the cosine of u is root 2 over 2. Now for v, we'll have to draw a triangle. So remember when you were given an x value, it always is in quadrant 1. Okay, cosine is the adjacent over the hypotenuse. So now we have to do Pythagorean Theorem. So this is like c squared minus b squared, then take the square root. So you're going to get the square root of 1 minus x squared. Keep in mind that you're not allowed to take the square root of that, right? That is fully simplified. That is what it is. And now let's just make ourselves a note. That means that the sine of v is root 1 minus x squared, and that the cosine of v is x. So when we go to plug it in the formula, we'll be ready. Yes?
How did you find the value? Like square root of 2?
Well, I did two things. First of all, I thought about the fact that tangent of 1 is at pi over 4. Okay? Also, if you did opposite over adjacent, you'd get 1 over root 2. Rationalize it. You could get root 2 over 2.
So you have to know, you have to use the...
You could use the unit circle or the triangle. It doesn't matter. Okay?
How did you come up with the value with using the
Sine is opposite over hypotenuse. So 1 over root 2 is sine, but you have to rationalize it. All right, so now we have the cosine of u plus v. So that's going to be cosine of u, cosine of v, minus the sine of u times the sine of v. And I'm going to plug them in. So I'm going to get root 2 over 2 times x minus root 2 over 2 times root 1 minus x squared. Not a whole lot you could do here to simplify. You could factor out that root 2 over 2 and write it as root 2 over 2 times the quantity x minus the square root of 1 minus x squared. That would be okay. I'd accept either one. Any questions there? Same idea as the previous problem, except now we just introduced an x. Last one. Sure. Yeah, I would accept either one of those. Yep.
Does this one get a lot of space?
I'm going to use about half of my page. If you have a little less than half, you'll probably be okay.
Wait, so what's your answer? The square root of 2?
Either one, if you didn't factor out the root 2 over 2. Okay. Last one. Solve for x. We have the sine of x plus pi over 4 plus the sine of x minus pi over 4 equals negative 1. What does it look like?
A combination of 2.
Yeah, there's two of them happening here. Do you see that? So this one is like the sine of u plus v plus the sine of u minus v is what's going on there. So we actually have to use two formulas. So you got to keep this straight. All right? Ready to plug it in? Okay, so I'm not going to write down the formula this time. Is that okay? All right, so we know in this case u is x and v is pi over 4, and that's actually true in both of these cases. So we're just going to plug it all in. So the sine of u plus v is the sine of u which is x, cosine of pi over 4, okay, plus the cosine of x, sine of pi over 4. So that represents this piece here. Okay? Plus, now we got to do the sine of u minus v. So the sine of x, cosine of pi over 4, minus the cosine of x, sine of pi over 4. And remember, that's equal to -1 in this case. So this piece is here. All right, now we're just going to simplify. So do you see what can happen here? I don't want to do any factoring yet. I want you to take a look at the individual terms. So like this is a term, this is a term, this is a term, this is a term. Do you see what happens? These cancel here, correct? They're the same thing. One's plus, one's minus. So those cancel. These are the same terms. So if there's one of these and one of these combined to 2. Okay? So we get 2 sine of x cosine of pi over 4 equals -1. What can I do now? I could start there, but I'm not going to. I want to, yes, insert any unit circle value you can first. Okay? So cosine of pi over 4 is root 2 over 2. And I'm just going to change the order there. It's multiplication. It doesn't matter. So now I have 2 times root 2 over 2. The 2's cancel. I'm left with root 2 sine of x equals -1. Okay? Divide by root 2. So I have the sine of x equals -1 over root 2, which is the same as negative root 2 over 2. Once you rationalize. Still not done. Now I got to figure out where is sine negative root 2 over 2. So this is like what we did in 5.3. 5 pi over 4 and 7 pi over 4. And those are your solutions. Questions?